Our last speaker in this, for the speaker part, is Dr. Peter H. Diamandis, who's the founder and vice chairman of International Microspace, founder and director of International Space University, and he's a lot of other things. And we'll just listen to Dr. Diamandis.
It's always a pleasure to follow Tom. He wakes the audience up for me, so I can be back to sleep now. Everybody's making disclaimers. I have a disclaimer to make as well. I fully support the DCX as a vehicle and think it's a great concept, which I hope we'll all be hearing a little more about. I'm going to talk to you not about concepts in general, but I'll talk to you about numbers. More specifically, numbers with dollar signs in front of them. And I think numbers with dollar signs in front of them make all of us expert mathematicians. And with that, I've got a couple of big graphs in here. You know, Tom, I thought you were talking when you were going with that dog barking routine was to shoot the dog. And then I thought you were going to go have a shoot Congress as well, but I guess you never got there. My disappearing act back here. Bring these numbers into focus. Four things I want to talk about. There we go. What are the costs inherent in a traditional launch system? I want to make all of you experts in how to cost out a launch vehicle. What is the best, in other words, the lowest that we hope to get with traditional expendable launch vehicles? What's possible single stage to orbit? And then fourth, and most importantly, how will something like a single stage to orbit affect commercial space financially? Because as far as I'm concerned, after spending 4 years or so trying to get a launch vehicle going, and spending 80 or 90% of my time trying to convince investors, you can have the best technology in the world, but if it doesn't make a profit, forget it. So, number 4 is the critical element here. These are approximations. These are to make a point. But if you took the launch vehicle and broke it down into its constituent parts, on the hardware side you'd have propulsion, structures, guidance, avionics, control system. You have software, and you have people. Now let me define people. What I call people are mission support. And that's people when you have a satellite and want to come and launch on my vehicle, you'll come to me 18 months in advance. And at that time, I'm going to put 10 people on your mission, for example. And over the course of that 18 months, those people are going to be taking care of procuring this motor and that avionics and assembling it, and making sure the range costs and Department of Transportation costs. And everybody's madly writing down numbers over here. So that's your mission support costs. Then you're going to have a few people who are going to be at the range finally integrating the satellite with the launch vehicle. Those are two different groups of people. And I'll explain why in a minute. Then you've got your range costs, you know, what you're going to be doing at the range. And then you've got the miscellaneous, transportation, facilities, insurance, and other stuff. And again, those numbers approximately add up to 100%. The thing this does not include, I'll make very careful in the commercial case, is recovering your R&D. You've spent $50 million, $100 million, $2 billion to build this launch vehicle, and you have to recover that money over time. And of course, because we're in the commercial business, you want to make a profit. So you've got to add those numbers on. So if this were a $10 million launch vehicle, we'd be paying $3.5 million for those solid rocket motors, or those LOX hydrogen motors. Any chemists in the audience? Physicists? Okay, well, this is an energy potential curve. And I submit to you where we are today in our cost minimization process is where this little dot is right there. And we're looking at national launch systems and space lifter, and we're looking at what the Russians are doing and so forth. What we're doing is we're diddling around in local minima. In other words, what we're doing is we're looking over the next little hill and saying, well, you know, if we can come down over here by volume, well, we can reduce the cost. Yeah, that's fine. And if we build a better guidance system, or we get the motors for free, or so forth and so on. But the fact of the matter is, what we really need to do if we get the cost down an order of magnitude or two is forget about this local minimization and minimize on the entire system, which is what SSTO is doing. And that's revolutionary versus evolutionary. Okay. So, again, these are for the purpose of demonstration, but what the heck. Where we are again, I gave you these first column numbers before, in propulsion structures and so forth. Those are the same numbers I put up. If you imagine that you're going to take current systems and evolve them, meaning large numbers, well then I propose to you that you could get your propulsion down from 35% or so relative, cut it by an order of 2, down to 15%. Or structures, mass producing them. Again, you cut it down by a factor of 2. Your control systems, even your software can reduce down. But the fact of the matter is, you're going to still need the same group of people to carry that launch vehicle through from when you come to me for a contract and I finally launch it. And the range operation costs really aren't going to change all that much. They'll change a little bit because you're doing more volume, but you're not going to massively change it. And you'll change your transportation facilities. A trucking company might give you a little bit more of a break. But you're bringing your numbers down from 100% down to 60% of your cost, and that's good. You know, I'll take that any day. But for what we've said before, it's not good enough. On the SSTO front, again, this is taking a little bit to the extreme, but I'll let other folks talk about that. You're not paying for your propulsion structures, guidance, control every time. You're reducing the number of people you need because this group of people is not ordering parts and assembling and making sure. They are essentially at the range doing maintenance on the vehicle, like an airplane, and making sure it's going to launch correctly. You're going to have still some range costs and still some transportation facility costs. And it's in this way, again, with numbers with dollar signs in front of them, that you get, hopefully, an order of magnitude cost reduction. Now, I'm going to take you guys to Basic Finance 101. I submit to you that with SSTO we can get a factor of 10 cost reduction. Now I'd like to find out, what does that do to your commercial space venture? All of you have heard about the low Earth orbit explosion that's occurring right now. There's Iridium, Constellation, and Orbcomm, and Starsys, and Leo 1. Lots of constellations. And in fact, I'm involved personally right now in 4 different constellations that we're designing and building for a whole slew of things. But when it comes down to return on investment is the key parameter, making a profit. Now I'm going to define a few variables here, calling I the invested capital. If you want to go and you want to build a LEO low Earth orbit system, if you want to build Iridium, that invested capital is something on the order of $3.5 billion. If you want to build an Orbcomm or Starsys, it's $250 million or thereabouts. Your profit is how much money you make at the end of a year after you've subtracted what you sold the service for and what it cost you. That's your profit. The value of your company after any years is a key parameter. After 5 years of having your company, how much can you sell it for? And if it's more than you invested, then you made money, and if it's less, then you lost money. Number of years is a key parameter. Investors today want a return on their investment, not in 10 years, 20 years. They want a return on their investment in 3 years. They're not going to invest in something unless they can see a return in 3 years. Maybe a little more. Your price to earnings ratio. Your PE ratio is a stock market terminology, if you would. they typically value a company depending on how much profit it makes today. If you make $2 million of profit this year, if you're a high-tech company, then you're valued at 20 times your earnings, or $40 million. Okay, so you're at factor of 20. If it's a restaurant, it's 5 or 10. If it's a supercomputer firm, it might be 30 or 40. Orbital Sciences, when it went public, went out with a PE of 22. The value of your company, again, is your PE ratio, or 20 times your profits. Your return on investment is the ratio of your value of your company n years out divided by the investment to 1 over the n number of years minus 1. We'll go to this calculations in a second. So take those for granted or check them if you want. I'd like to find out what happens to a satellite system. A 25 satellite low Earth orbit system. Each satellite has a 5-year lifetime. That's pretty typical right now what the LEOs are projecting. The non-recurring, how much you have to invest for those. But I figured it was about $4 million per satellite, and 3 low-cost or 4 low-cost medium launch vehicle launches at $100 million, and then your support costs. About $250 million, which is what a number of the large LEO systems, or little LEOs as they call them, are investing. On your non-recurring, if you just reduce the launch cost by a factor of 10, you reduce the investment from $250 million down to $160 million. All right? On the recurring basis, your satellites have an average lifetime of 5 years, which means every year on the average you have to replace 1/5 of the satellites. So which means you've got about $20 million in satellite cost every year on replacement satellites. You're replacing 5 of the 25 satellites because they have a 5-year lifetime. Right now with small satellites, $6 million for a 500-pound satellite would be a damn good price. So I call it $6 million per launch of one of these satellites. That's $30 million for launching these 5 satellites each year. And then $7 million of support costs give you an annual operating budget of $57 million to support this constellation. Again, if you reduce the launch costs by 10% down to 10%, your annual operating costs are $30 million instead of $57 million. What I assumed is you're typically making about a 8 to 10% profit in these systems. You can play with those numbers later if you want. So if you're making $5 million of profit, which means your total income is $62 million, 57 is your cost and $5 million is your profit. In this case over here, if you're able to get the same amount of money for your services, your profit is $32 million. All right? Now let's find out how these numbers affect your return on investment. In case 1, again, your profit of $5 million, 3 years out, your initial investment is $250 million, your PE is 20. At the end of those 3 years, the company value is $100 million, which means you're losing money at the rate of 14.5% per year. Okay, you can adjust those. You can say your profit's going to be double that. That's fine, but it's not necessarily that number. It's when we compare it to what happens if you reduce your launch cost now by a factor of 10. In case 2, what have we done? Your profit's gone from $5 million to $30 million. Number of years is still the same. Your investment has dropped from 250 to 160. The price earnings ratio is still the same. But all of a sudden, you've gone from losing 14.5% per year to an investment return of 55% per year. And I submit to you that launch costs are the driver, and they're the driver specifically here. You bring the cost down, and the 30,000 business plans that are out there right now that have failed because they couldn't get financing will be able to get financing. And that's all I wanted to say, folks. Thanks, and we'll go to panel session.